Hello all. Good evening, good afternoon, or good morning, whatever it be the time. Once again, welcome to our channel Chemflix, and today we're going to discuss about the new chapter, one of the most important chapter, that is aldehydes, ketones, and carboxylic acid. Today here, okay. So the chapter 12, aldehydes, ketones, and carboxylic acid. Okay. So before going to this chapter, if you are new to this channel, please click on the subscribe button, and also if you like this video or if you found this video useful, click on the like button and also share among your friends. Okay, and if there is any suggestion or any doubts, you can ask me in the comment section. Okay, so once again, welcome to this channel Chemflix. In this chapter we are going to discuss about these aldehydes, ketones, and carboxylic acid. You know what is the functional group of aldehyde, functional group of ketones, and functional group of carboxylic acid? Because you already studied in your 10th standard about this functional groups in detail. That is about the aldehyde, ketones, and carboxylic acid. You can see here. In all these cases, you can see a carbonyl group. Okay, that is what is called an organic compound. These aldehydes, ketones, and carboxylic acid are a group of organic compounds. There you can find a carbon-oxygen double bond. Okay, so carbon-oxygen double bond. That is the important thing. Carbon-oxygen double bond. I will show you what is the exact functional group of aldehyde, ketones, and carboxylic acid. Okay, all of you please listen here. This is RC double bond O. If there is a hydrogen atom that is attached to a carbonyl group other than an alkyl group, this is an alkyl group. Okay, this is a ALKYL group. Okay, alkyl group, and this is a hydrogen atom that is directly attached to the carbonyl group. This is the double bond O, is called the carbonyl group. Then it can be called as what? It can be called as aldehydes. Okay, and if two alkyl groups are substituted or two alkyl groups are attached to this carbonyl group, then it can be called as ketones. If two alkyl groups, this is alkyl group, this can be called as alkyl group. If two alkyl group are substituted, for example, CH3 C double bond O. This is the simplest ketone, you know, CH3 C double bond O CH3. This is the common name is acetone. The common name is acetone. Okay, the common name is acetone here. And again we are moving to the third one, that is about the carboxylic acid. This is the functional group, that is R C double bond O OH. That is, and OH, what do you mean? What is the functional group OH? This is an alcohol. Okay, so a hydroxyl group, this is a hydroxyl group. A hydroxyl group is attached to this carbonyl group other than an alkyl group, then it can be called as carboxylic acid. This is the functional group of carboxylic acid. So in this chapter we are mainly discussing about the properties, methods of preparation, and some of the reactions, how to name an aldehyde or a ketone or a carboxylic acid, what is this acidity of carboxylic acid, so on. Okay, so please stay here with a positive attitude. Okay, so moving to the next slide, that is about the nature of carbonyl group. What is the nature of this carbonyl group that is present in both in aldehyde and ketone? Okay, please keep this carboxylic acid away for a minute. In the case, we are going to discuss about the nature of carbonyl group in aldehyde and ketone. Okay, so here, okay, both of the nature of carbonyl group in both aldehyde, ketone, and okay, whatever be. The structure of carbonyl, okay, the C double bond O is made up of one sigma bond and one pi bond. Okay, already we know that in the chemical bond of chapter 4 of 11th standard, we know that if there is a double bond, then it is sp2 hybridization. And if there is a triple bond, then it is sp3 hybridization. And if there is, sp3, no, it is sp. Very sorry, this is sp. Okay, if there is a single bond, then it is sp3 hybridization. Okay, so here you can see a double bond. So this is, of course, it is sp2 hybridized. The hybridization here is sp2. Okay, and here one of this bond is sigma bond, that is head-on collision, the bond formed by the head-on collision. Okay, and one is pi bond, that is by parallel overlapping. Okay, so the structure is it is made up of one sigma and one pi bond, and of course it is a sp2 hybridization. Okay. The carbon atom is joined to 3 atoms by sigma bond. 3 atoms means okay, 3 atom means here it is C double bond O, and two more vacancies are here to satisfy the valency of the carbon. Okay, and here you can see 3 sigma bonds and 1 pi bond. You can see this is the parallel overlapping. Okay, 1 pi bond, and this is a sigma bond, this is a sigma bond, and this is a sigma bond. And since the bond utilizes sp2 orbitals, you know what is the bond angle of sp2 hybridized orbital? It is 120 degree. Okay, and hence carbonyl group is planar, and of course it is a trigonal planar in shape. So that is all about the nature of carbonyl group. That is carbonyl bond is made up of 1 sigma and pi bond, and of course it is sp2 hybridized, and there is 3 sigma bond and 1 pi bond, and the bond angle is 120 degree and the shape is planar. Okay. Okay, you can see here this is 120 degree and the shape is planar shape. Okay, planar shape. Moving to the next slide about the nature. Okay, we are going to see, there you just discussed about the shape, okay, and the hybridization, and now we are going to discuss about the actual nature of this carbonyl group. This C double bond O bond is polarized due to higher electronegativity of oxygen relative to carbon. You know that oxygen is relatively high. Okay, oxygen is high electronegative compared to this carbon. Therefore, this attract the shared electron pair towards itself, and it acquires a partial negative charge. Therefore, of course, this carbon gets a partial positive charge. That means there you can find a polar nature. Okay, polar nature. Okay, you can see a polar nature in the carbonyl group. Okay, so polar nature is due to the higher electronegativity of oxygen related to carbon. Okay, and it is indicated by the following resonating structure. You can see the resonating structure, that is, this resonating structure is formed by pulling of this shared electron pair towards the oxygen due to the higher electronegativity of oxygen compared to the carbon. Okay, so that is the reason for so many properties of these aldehydes and ketones. Okay, we can see this aldehydes and ketones. Okay, so we're moving to the aldehydes. They are compounds in which the carbonyl group is bonded to a carbon and hydrogen. We already discussed in our first slide, that is, there you can see an alkyl part here. This is an alkyl part and this is a hydrogen. Okay, aldehyde in which the carbonyl group is bonded to a carbon and hydrogen. This is the carbonyl group and it is bonded to the carbon. Alkyl means it is a carbon. You can see here CH3, C double bond O, H. This is an aldehyde. C2H5, C double bond O, H. This is an aldehyde. There you can see this particular group, this is bonded to this carbonyl group is bonded to this carbon, and we can generally call it as R, that is alkyl. So here you can see 2 carbon, therefore this is ethyl, and there you can see only 1 carbon, therefore it is methyl. Okay, so this is generally it is an alkyl part. Okay, so CH3, C double bond O, H. This is what is the name. There you can find 2 carbons. So the name will be ethanaldehyde or ethanol. And here you can find 3 carbon, C2 plus C3 carbon. Therefore the name will be, what is the name? Propanol. Okay, so that is propanol and this is ethanol or ethanaldehyde. Okay, whatever be. So what we done here is we are removing, okay, the parent chain. You know that the parent chain will be ethane, and here we are removing this E and we are substituting this E with Al for getting an aldehyde. Okay, moving to the next slide about the nomenclature that we already discussed here. So there you can find 2 names, that is common name and of course that is IUPAC name. IUPAC means our International Union for Pure and Applied Chemistry, and this is a common name. You know, we are commonly called as acetal and so on. Okay, so here the common names of aldehydes are derived from the common name of the corresponding carboxylic acid. So you know that vinegar, okay, it is common in your kitchen. So it is commonly called as what it is? Acetic acid. Okay, acetic acid. So in the acetic acid, what is the structure? It is CH3COOH. There you can find two carbon. This is the first carbon and this is the second carbon. Okay, and this it is commonly it is derived from the common names of corresponding carboxylic acid. So what will be the name of the aldehyde containing two carbon atoms? It will be acetal. Okay, I will show you. That is CH3CHO. Okay. So that is the common name is derived from its corresponding carboxylic acid by replacing the ic acid with the Al, with the aldehyde, acetaldehyde. Okay. Okay. So moving to the second point, that is the location of the substituent in the carbon chain is indicated by the Greek letters alpha, beta, gamma, delta, etc. That is here. Here, this is our, okay, let me change my pen color. Okay, give me a minute. Okay, I'm going to change the pen color. Okay. So here you can see this is the CHO. This is our functional group and it is directly attached to the alkyl group, that is CH3. So here you can call this is the alpha carbon atom. This is the alpha carbon atom. Suppose I am writing another one example of aldehyde, that is of course of a propanaldehyde. Okay, CH3, CH2, CHO. There you can find three carbon. That is the first carbon, this is the second carbon and third carbon. And obviously the name will be propanal. Okay, the name will be propanaldehyde. Propanaldehyde. Okay, in this case, please listen here. All of you, please listen here. In this case, this is our functional group. Okay, this is our functional group and this functional group is directly attached to this CH2 group. Okay, so this CH2 will be the alpha carbon and this CH3 will be the beta carbon. Okay, I'm going to change the color of the pen. Okay, it's not. Okay, you can see here this is the alpha carbon atom, because this functional group is directly attached to the first carbon, that is alpha carbon, and then again the next carbon will be termed as beta carbon. So this is the beta carbon, this is the alpha carbon. Okay. And again if there is another one carbon, then it can be called as gamma. If there is any other one, then it is delta and so on. Okay. Now moving to the IUPAC name. Okay, the IUPAC name of open chain aliphatic aldehydes are derived from the names of the corresponding alkenes by replacing the ending E with Al. We already discussed that if there is two carbon atoms, what will be the name? It is ethane. And if there is an aldehyde group, that means CH3CHO, then we have to replace this E with Al. So what will be the name? Ethanol. Okay, if suppose there is three carbon atoms, that is CH3, CH2, CHO, the word root will be propane is the parent chain, and we have to remove this E with Al, that is the name will be propanol for this corresponding aldehyde. The name will be propanol. What is the name? Name will be propanol. Okay, and in case of aldehydes, the longest carbon chain is numbered starting from the carbon of the aldehyde group. So we have to start the numbering from here. This is the first carbon, this is the second carbon, I already mentioned here. Okay, moving to the next slide. This is there you can see some of the this is the table that I attached here from your text, that is NCERT textbook. You can see the common names and IUPAC names are here. Of course, there will be a question of naming an aldehyde from the CBSE. Okay, you can see so many previous questions there by naming or give me the name of that particular structure. Okay, so so thank you all once again, and if you find this video useful, please share among your friends. Okay, thank you all.